Hi, welcome back. In today's lecture series, we are going to learn about the rheostatic braking of DC shunt motor. So, in previous class itself, already we seen the difference between the electrical braking and the mechanical braking and the advantages and disadvantages also. So, in electrical braking, there are three types of electrical brakings are there. One is nothing but rheostatic braking, and second one is plugging, and third one is regenerative braking. And these are the three different types of electrical braking which we are applied to bring the motor to the initial position or to control the speed of the machine. Okay. So already we are discussed this kind of rheostatic braking where we can apply. Okay, you can see the crane. You can see the crane which is lifting the load, and it will be kept another side. So after the removal of load, the speed of the host, the speed of the crane and the host will be too high. So that during that time, the crane, the motors inside the crane is act as a generator. It acts as a generator. So that there we have to apply the rheostatic braking. We can use it for the crane hoist and as well as paper rolling machine. As well as the paper rolling machine or steel industry. Okay, we can apply for the emergency brake to bringing the motor to the original position. Okay. So now you can consider the rheostatic braking of this shunt motor. So here, the first image is nothing but braking running system. It is nothing but a running system. So here, and this is the supply voltage. And here from the supply voltage, here we are getting the supply current. That is nothing but line current which is coming out from the line is divided into two parts according to the current division rule. One is the current which is coming from the line is divided into two parts. One is the current through the armature. Another one is the current through field. The current which is coming out from the supply from the line which is taken into two way. One is for armature, another one is for field. So here we are exciting the field winding, and also we are providing the current to the armature. So here now this machine is act as a motor. So during this running condition, the electrical energy is converted into the mechanical energy. Rotary motion. This is normal operating condition of DC shunt motor. Why it is called shunt motor means here the field winding and armature are connected in parallel. That's why it is called shunt motor. Okay. If you go for the braking system, so what is the difference between the running condition and braking condition? Just you can see. Here also the same supply voltage is there, but the current which is coming from the line which is only flowing through the field winding. The line current in a running condition. The current is flowing through the field as well as armature. But in braking condition, the line current which is only entering into the field winding. And what about the armature? Here the armature is disconnected from the power supply. And after that a variable rheostat is inserted across the armature. So what is our observation from the running condition into the braking condition? Number one, from the running condition to the braking condition, number one, we have to disconnect the armature from the power supply. And the field remains same. First point, we have to disconnect the armature from the power supply. And second point, the field remains same. It always connected with the power supply. And third one, across the armature, we have to insert a variable resistance. Across the armature, we have to insert a variable resistance. So, at this case, the supply current which is entering only to the field winding. So, at this case, the motor is act as a generator. The motor is act as a generator. So, it generating the electrical energy from the kinetic energy. From the kinetic energy of the rotor. Okay. So, that generated electrical energy can be the generated electrical energy can be circulated through this variable rheostat. It can be circulated through the variable rheostat. Am I right? Just you can see here. This current can be circulated through this variable rheostat. So the generated current is converted into heat energy with the help of variable rheostat. So with the help of rheostatic braking, the kinetic energy is converted into electrical energy. After that, we are not utilizing the electrical energy, but we are converting the electrical energy into the heat energy with the help of variable rheostat. There also we are producing the heat. Here also we are producing the heat. And what is the difference? It is very smooth operation. It is very smooth operation when compared to the mechanical braking. And this is the rheostatic braking. Okay. And this is the assessment 1. Which of the following is not the method of electrical braking? Number 1, plugging, or it may be called as counter current braking. Second one, rheostatic braking, or it may be called as a dynamic braking. And third one is regenerative braking. And fourth one is eddy current braking. Can you guess which one is not the electrical braking method? Okay, put your comments in the answer in the comment section. So, in this rheostatic braking, in this electrical braking, the dynamic braking, or it may be called as a rheostatic braking, it is when very smooth operation, but one limitation is that here the suitable value of variable rheostat should be inserted across the armature. That is one thing. And the field is remain same. The field is remain connected with the power supply, so that only the rheostatic braking is possible. Okay. And this is the assessment 2. Which of the following is dynamic braking? Which of the following is dynamic? Reversal of field connection. When the field is there, we have to reverse the field connection, or reversal of armature, or addition of equal and opposite field. We are adding the one more field winding, whether it's equal or opposite. And the removal of armature from the machine. And which one is an dynamic braking or rheostatic braking? Put your answer in the comment section. Okay. And these are the reference papers for the rheostatic braking of DC shunt motor. Thank you.